in this collage. So what is that? In our course, everything features. There is some fluid mechanics, there is some heat transfer. Probably all of them get applied in the technologies we are going to study. Just look at this. Somebody may say it must be a photograph of Diwali of Noida or Delhi. Or somebody may say it must be a photograph of London or New York. But do you know, this is not some Diwali night. It is how the Reliance Industries, world's largest refinery at Jamnagar, will look like every night. Pura Deep Jyoti. Okay, this is every day. Every day evening, when the sun sets, you will see the refinery glittering and glowing like this. Okay, so that is how the life of a chemical engineer in a refinery is. Okay, this is actually a shot of the Reliance refinery, world's largest, at Jamnagar, Gujarat. Someday, कहीं उस रास्ते में जाओ, drop in and have a look. Let's come to what is a process. The definition known to you, but I'll just repeat it. So the word process is used and misused in all contexts, but in our perspective, chemical engineering perspective, in fact, chemical engineering and process engineering almost the same. There's no difference. So it's another name, that's all. But in a formal definition, process is defined as the engineered sequence of chemical, physical, mechanical, and biological transformations for converting raw materials into a variety of useful products in the most optimum fashion. Remember, the objective is convert raw material into useful product. And to convert the raw material into useful product, you may have to do some chemical transformation, some physical transformation, mechanical transformation, biological transformations. Then only the raw material becomes the useful product. And of course, we must do it in the most optimum fashion. Chemical transformation is like reactions, oxidation, reduction, etc. Physical transformation is like filtering, distillation, heating, cooling. All these are physical operations. You know the difference between chemical change and physical change. Then mechanical operations are those, the sort of physical operation, but a little more, no tougher than the physical operation. For example, the ore of many minerals, they are not available as fine powder. You will find them as thick rocks, right? You have to break the rock into, smash it, pulverize it, and make it into a fine powder. So that is a mechanical transformation, right? So such of those operations are known as mechanical transformations. Okay, you'll be doing some of these in your practical laboratory also. And biological transformations are those where, one bacteria can convert by fermentation something into something, right? So you can see chemical transformations include unit processes such as oxidation reduction. Physical transformations include unit operations such as distillation, extraction. Mechanical transformation is crushing, grinding, filtering, all those. And biological transformations include fermentation, etc. We have used two words, unit process, unit operation. Unit process are the chemical reactions, and unit operations are the physical transformations like distillation, extraction, etc., where oxidation, reduction, alkylation, many of those chemical reactions, they are called in the chemical engineering dictionary as unit process. Remember, mechanical engineers have a different convention of unit operations and unit process for their workshop, milling, lathe, etc. We are not to confuse with that. Our unit process means chemical reaction, unit operations means physical transformation such as distillation, extraction. Okay, mechanical transformation in a way or physical transformation, but some heavy duty operation like crushing, grinding, and filtration, dirty operation, right? And biological transformation using microorganisms. That is the whole biotechnology field all about. Let's just have a look at some of the selected milestones in the history of the chemical industry. Selected milestones in the history of the chemical industry. Like you see, when we go from Banastali to Jaipur, we cross Chaksu, which is a milestone, and after Chaksu, you come to Sanganer Airport, and then Sindhi Camp. So these are milestones. Like that, in the chemical industry, what are the milestones to remember? Okay, let's have a look at some of them because that's what is going to tell us what we are going to study in this course for the rest of this semester. How? Start with 1746. John Roebuck starts producing moderately concentrated sulfuric acid in the lead chamber process on an industrial scale. Moderately concentrated. 50%, 60% concentrated sulfuric acid in the lead chamber process, which is now outdated. Of course, we are not going to discuss it in our syllabus because it is phased out. There is no plant in the world which makes by lead chamber process. It's a very cumbersome process, but to begin with, that is the way when sulfuric acid was made. Remember, sulfuric acid is one of the very important chemical because there is a quote which says that sulfuric acid is the quantum of sulfuric acid consumed in a country. You can relate to how developed that country is. That much importance sulfuric acid holds. So 1746, John Roebuck. Then comes 1789, Nicolas Leblanc develops a process for converting sodium chloride into sodium carbonate. Wow, sodium chloride is abundantly present, seawater, right? Convert it into sodium carbonate, NaCl2, Na2CO3, sodium carbonate. Leblanc developed a process in 1789. In many ways, this process began the modern chemical industry. From its adoption in 1810, it was continuously improved over the next 80 years until it was replaced by the Solvay process. Remember, you have an idea of the Solvay process where ammoniation is done to the brine, then carbon dioxide is added, and then the reaction of separates, then you form ammonium bicarbonate or something, and then sodium bicarbonate comes, and that on heating forms sodium sodium carbonate. So Solvay process, sodium carbonate is one of the most important chemical in the industry and is consumed, produced in large scale. India is one of the largest producers of sodium carbonate. The Solvay process in many of the Western countries, they are not using it, but India still uses Solvay process, and the Tata Chemicals plant near Dwarka, right? So is one of the largest plants in the world for making sodium carbonate. जो द्वारका तीर्थ यात्रा में जाएंगी वो टाटा केमिकल प्लांट का जरूर देखना, सोडियम कार्बोनेट. 1831, Peregrine Phillips patented the contact process for manufacturing concentrated sulfuric acid. Remember, lead chamber process produced moderately concentrated, 60%, 70%. But we want 90%, 98%. So Peregrine Phillips made the contact process for manufacturing concentrated sulfuric acid. We are going to study this technology. We'll be, of course, studying the Solvay process and sodium carbonate also. And the first mention of heterogeneous catalysis for a large-scale process. So the contact process for sulfuric acid is another milestone. For various reasons, the process only became a success at the end of the 19th century. So 1831, Peregrine Phillips patented it, but it took several years before the technology became widely adopted. But today, that is how contact process is the only way by which sulfuric acid is made. Then comes 1850. That is the first oil refinery consisting of a one barrel. Just imagine, just one barrel still, which is built in Pittsburgh, Pennsylvania, USA by Samuel Keir. That's the beginning of the petroleum refining industry. 1856, seeking to make quinine, William Henry Perkin, at the age of 18, synthesizes the first aniline dye, morphine from coal tar. This discovery is the foundation of the color industry, dye synthesis industry, one of the earliest successful chemical industries. Okay, so this is another milestone. The synthetic aniline dye, morphine. Then this came, of course, we just saw it, Solvay process. Time has come, 1863. Ernest Solvay perfects his method for producing sodium carbonate. This process started to replace the Leblanc process in 1873. Then comes 1864, another landmark year, because the British government passes the Alkali Works Act in an effort to control environmental emissions, the first example of environmental regulation. So you can say the first law for environmental conservation in the chemical industry happened in 1864 by the British government Alkali Works Act. Then comes 1874. Henry Deccan developed the Deccan process for converting hydrochloric acid into chlorine. Remember, hydrochloric acid, you know why it is used for toilet cleaning, right? So it has very little use, and chlorine is more in demand, and hydrochloric acid, how to convert it into chlorine. So Deccan made the process. And in industry, in many processes, hydrochloric acid comes as a nuisance byproduct, and you can't just throw it, right? It is a acid pollution. So more essential, hydrochloric acid is converted into chlorine, which has very wide use. So this is the Deccan process. Then comes 1900 with the coming of a large-scale electrical power generation. The chloroalkali industry is born. How does chloroalkali industry? Remember, sodium chloride does not become caustic soda by any method you can think of. The only method by which sodium chloride can break into caustic soda is electrolytic cell, which is a huge consumer of power, right? So with the large generation of electric power, the chloroalkali industry is born. Then comes 1905, Fritz Haber and Karl Bosch developed the Haber process for making ammonia, right? So for nitrogen is a very essential nutrient for the plant, and very few plants could absorb the atmospheric nitrogen like the legume plants, pulses, but all plants were not capable of taking. Of course, the atmosphere has got 79% nitrogen and 21% oxygen, but still plants are not capable of capturing this ammonia into the plant system for use as a nutrient. So Fritz Haber and Karl Bosch found a way of fixing the atmospheric nitrogen in the form of ammonia, which can be used as a fertilizer, and ammonia was converted into urea. So this Haber and Bosch got their Nobel Prize also for their discovery of this Haber-Bosch process, ammonia making. Okay, then come 1907, Wilhelm Norman introduces the hydrogenation of fats. Remember, no, the oils, edible oils we use has, you are aware, saturated fats and unsaturated fats. right? So it was felt that the unsaturated fats are not good for health. So you will keep reading this controversy, which is good, saturated or unsaturated, but the argument continues. But one thought was the unsaturated ones, fats. Unsaturated means what? It has got double bond, triple bond, etc. Saturated means no double bond, triple bond, right? So saturation, fat hardening means hydrogenation of fats. So the edible oil is given a hydrogenation treatment so that the hydrogen will saturate the unsaturated bond and make the edible oil into what you call as vanaspati, right? So vanaspati is nothing but edible oil which is hydrogenated, where the unsaturated fats have got saturated, and that is how it becomes thick, and you have to lift it with a spoon, and put it for cooking purpose. That is the vanaspati, hydrogenation of fat, 1907. Then come 1909, Leo Baekeland patents Bakelite, the first commercially important plastic, which was commercialized shortly after. So, beginning of the polymer industry. Bakeland makes Bakelite. That's how his name came, Bakelite. And Bakelite became one of the very popular plastic, almost all gadgets, switchboards, in the black looking switchboards in the old houses, they were all made using Bakelite. Right. So it was a major breakthrough. Okay. Then comes 1920. Standard Oil Company begins large-scale industrial production of isopropanol from oil, the first large-scale process using oil as feedstock. So, Standard Oil, one of the global majors in oil and gas industry, starts making isopropanol from crude oil, the first large-scale process using crude oil as a feedstock. Of course, isopropanol was otherwise made from agricultural sources like the fermented cane juice, that you get ethanol and it can be reacted to convert into isopropanol, etc. But first time Standard Oil started making isopropanol from oil. By when the word oil means crude oil. Okay, 1923, Matthias Pair of BASF, global major BASF, develops a high pressure process to produce methanol. Methanol is another important chemical, CH3OH, the lowest alcohol. Right. So Mathis Pair of BASF developed a high pressure process to produce methanol. This marked the emergence of synthesis of large volume organic chemicals. So organic chemicals were made in small scale. Large volume production of organic chemical started from the point of BASF methanol process. Franz Fischer and Hans Tropsch, Fischer and Tropsch, they developed the Fischer-Tropsch process, a method for producing synthetic liquid fuel from coal gas. Imagine coal and petroleum, crude oil, have some common ways of originating. Both came by decay of vegetable matter, which got very deep down there, and the action of pressure and temperature converted the vegetable waste into organic material, and large scale anaerobic bacteria acting converted into crude oil. Right? You can say coal is the solid, and to form petrol, you need to have coal must further, undergo several years of change to get converted by the anaerobic bacteria into crude oil. The process was widely used by Germany during World War II for the production of aviation fuel. Remember that converting coal, solid fuel, into a liquid fuel, making a synthetic crude oil. That is what is Fischer-Tropsch process. So coal was converted solid fuel into a liquid fuel, crude oil. That is the Fischer-Tropsch process. Then comes 1926, Fritz Winkler. Fritz Winkler introduces a process for commercial fluidized bed coal gasification at the BASF plant in Luna, Germany. Right, so Winkler process. So fluidized bed coal gasification. Of course, we will see later in the coal technology, we may do coal can be converted into coke, that is a pure carbon, by removing the impurities in the coal. Right, so coal carbonation, then gasification. Coal can be combusted like burning to release energy, coal combustion. Then coal gasification is converting coal into gaseous product, but like methane, ammonia, etc., not carbon dioxide. So combustion and gasification are different. Coal gasification is burning the coal, converting the coal into gas, which is predominantly methane, carbon monoxide, carbon dioxide, etc. Okay, and coal liquefaction, that is the Fischer-Tropsch process for converting the solid fuel coal into liquid fuel. Then comes 1930. First commercial steam reforming plant is constructed by the Standard Oil Company. You just saw Standard Oil Company, steam reforming. That is a hydrocarbon is given a steam treatment to reform it into the desired chemicals. We'll be studying this under the ammonia making. Then first commercial manufacture of polystyrene by I.G. Foreman. Then Wallace Carothers discovers nylon. It's one of the important, products. You know how the word nylon came. It's very interesting. During the Second World War, both scientists in England and scientists in America, USA. When I say America, it means United States of America, and they were working on finding fibers because Germany had a huge control over rubber product. So they were looking for different products to substitute rubber use. So Wallace Carothers discovered nylon. Nylon, the word came because a group of scientists were working in London in England and New York in USA. So from New York, the word NY was picked up, and from London, LON was picked up. That is how the word nylon came, right? To honor the group of scientists who worked both at New York and London, the product was named nylon. So there's a nice story. Read about it more in the Google Internet. Okay, the most famous synthetic fiber, and nylon was used for making those wind cheater jackets and the parachutes, like for the use for the Second World War. Then comes 1931, development of ethene, epoxidation process for the production of ethene oxide. So ethylene to ethylene oxide. All right, it's one of the major breakthroughs. We will be studying them under our petrochemical industries. Then comes 1933, polythene 2, discovered by accident at ICI by applying extremely high pressure to a mixture of ethene and benzaldehyde. Wow. Polyethylene. So polyethylene, depending upon polymerization of ethylene, so you may get a high density polyethylene or a low density polyethylene, each under different conditions. And ICI, in an accidental discovery by using extremely high pressure, they converted ethene and benzaldehyde into polyethylene. This is another. So the making of polyethylene came to be known as ICI process. It was that famous. 1934, the first American car tire produced from synthetic rubber. So till then, only natural rubber was used for making tires, automobile tires. And remember, in India, Kerala is one of the largest producers of natural rubber. Then comes Assam, Tripura, and then Karnataka. These are 3-4 states in which natural rubber is grown. Right, and the first American car tire produced from synthetic rubber, neoprene. So neoprene is a chemically made rubber. right, which imitates the properties of natural rubber, right? So this is considered another breakthrough in the evolution of chemical technology. Then comes 1936, Eugene Howdry. Howdry develops a method for industrial scale catalytic cracking of oil fraction. Remember, the refinery is something very funny, right? So you have crude oil, and every crude oil contains some quantities of light hydrocarbon, some quantities of middle boiling hydrocarbon, and some quantity of heavy boiling hydrocarbon. So depending on the nature, the quantities differ from crude oil to crude oil. For example, crude, Mexican crude, the Iranian crude, the Indian crude, they will all have different composition. So they will all have light distillate, middle distillate, and heavy distillate, but the quantities will be different. What is more useful is light distillates and middle distillates. Petrol, diesel, kerosene, they are the money spinners, right? And the heavy ones like fuel oil and tar oil, they are kachara, right? Now, from the heavier distillate converting into lighter distillate, that is breaking a large hydrocarbon into small hydrocarbon, cracking, tod dalo, tod dosko, right? A long hydrocarbon is cracked to make small hydrocarbon. That is cracking, and catalytic cracking process was introduced by Eugene Howdry. Remember, it's not all that easy. There are a lot of problems. We will be studying in the petroleum technology about this catalytic cracking process. Okay, and the most important modification was the introduction of then the Howdry's used the catalytic cracking, which was further improved into fluidized bed catalytic cracking, FCC. So fluidized catalytic cracking. This was in 1941. Then comes 1938, commercialization of the alkylation process for the production of high octane. You know, it is isooctane which has the highest octane number. Octane number is the indicator for telling how good a fuel is, right? So, how to make isooctane? So, 2,2,4 trimethyl pentane can be reacted to form by alkylation reaction. You may do a dimerization, right? Just two molecules merge to form a larger one, right? The polymerization is long chain, right? Dimerization is just two monomers sticking together. Dimer. Trimer means three molecules sticking together. Trimer, right? So for the hydroalkylation process, which is so you add a alkyl group to a smaller hydrocarbon to increase say a pentane into octane, right? So pentane is 5 carbon, so you bring another 3 carbon, so make them react so that the product will be 8 carbon, that is closer to octane. So that is how the alkylation reaction came. Otto, we'll be studying it. Otto Rollin discovers the hydroformylation reaction for the formation of aldehydes from alkenes. Wow. Then comes 1939, start of large-scale, low-density polyethylene. Polyethylene is polyethylene, LDPE. Production at ICI plant, that is the LDPE using high-pressure process. Start of large-scale polyvinyl chloride, PVC, production in Germany and in USA. Polyvinyl chloride, production in Germany and USA. Then comes 1940, Standard Oil Company. Remember, we have already seen Standard Oil already 2 times before. Now this is the 3rd time. Standard Oil Company develops a catalytic reforming to produce higher octane gasoline. Remember, the aromatics have a good octane number compared to the branched hydrocarbon. The straight chain hydrocarbon, they have very poor octane number, and The branched one, iso, ones have more, and or the cyclic ones, which is also called the naphthenes. So the cyclic ones also have good octane number. Then comes aromatic, right? But the crude oil contains very little aromatic. So how to convert a straight chain hydrocarbon into a cyclic hydrocarbon? That is, imagine, convert N-hexane. N-hexane is a straight chain hydrocarbon. Convert it into cyclohexane by dehydrogenation. So remove 6 hydrogen from the hexane, it will become cyclohexane. Remove another set of hydrogen, then what is that? Cyclohexane can be converted into benzene. Okay, so once benzene is formed, then I can make, other product, toluene, xylene, all those things. So Standard Oil developed a catalytic reforming. Remember, cracking is breaking a big hydrocarbon into small hydrocarbon. Reforming is converting a straight chain into cyclic and cyclic into aromatic. That is reforming. Then comes 1953, Carl Ziegler introduces the Ziegler catalyst for the production of high-density polyethylene. Remember, stereo-specific polymers, right? Precise properties, high-density polyethylene for making this Ziegler catalyst, right? So we'll be studying it in the polymer industry in the end of the course, right? The Ziegler technique for making high-density polyethylene. 1954, introduction of chromium-based catalysis for production of HDPE, high-density polyethylene, by Phillips Petroleum. This process became the world's largest source of polyethylene, 1956. Okay, then comes 1955, start of large-scale production of PET, polyethylene terephthalate, PET, a very vital input for the fiber industry. So Reliance had a big production of PET, polyethylene terephthalate, and 1957, the first commercial production of isotactic polypropylene happened, made possible by the development of the Ziegler catalyst. Isotactic is isotactic. There is a stereo-specific arrangement of polypropylene. Then comes 1960, commercialization of two industrially important processes, ethene to acetaldehyde, and that is known as the Wacker process, and acrylonitrile by the Sohio process. Acrylonitrile, another important petrochemical, right? Acetaldehyde, acrylonitrile, we will be doing them in the petrochemical industry. 1963, BASF developed the first commercial methanol carbonylation process for the production of acetic acid based on a homogeneous cobalt catalyst. So the raw material is methanol. The product is acetic acid, converting methanol into acetic acid. Methanol, remember, CH3OH, acetic acid is CH3COOH. This was done using a homogeneous cobalt catalyst. And in 1970, Monsanto, another global major in the chemical industry, built the first methanol carbonylation plant based on a homogeneous rhodium catalyst. They used the rhodium catalyst. Then comes 1964, many new and improved catalysts and processes are developed. For example, a zeolite catalyst for catalytic cracking, right? And the metathesis of alkenes. So these all happened in 1964. Then comes 1966. First low pressure methanol synthesis commercialized by ICICI. ICI was a British company, Imperial Chemical Industries. Then they dropped the full form and kept it as ICI. I think today it's been bought and sold, and it is part of some huge chemical conglomerate. Okay, so the low pressure methanol synthesis commercialized by ICI. Then comes 1970s. continued invention of new and improved processes and catalysts, more new, instead of more new processes, existing processes were improved and modified, and new catalysts were developed, birth of environmental catalysis, development of a catalytic converter for auto engine exhaust gas 1974. Right, so see, the automobile exhaust gas contains some unconverted hydrocarbon, and using a catalytic converter, it was possible to capture the unconverted hydrocarbon and finish it off. So this is another milestone. Then comes the energy crisis, 73 and 79. That is when the countries in Middle East, they almost held the world at random by jacking up the oil prices, and there was a huge energy crisis in the 70s all over the world. Then comes start of large-scale bioethanol from in USA and Brazil, right? So making large-scale bioethanol in USA and Brazil. This is another milestone. Then come the 80s. Several new catalytic processes are introduced. One of the most important is the selective catalytic reduction, SCR, for controlling NOx emission. What is NOx? Oxides of nitrogen. NO2, NO, nitric oxide, NO2. So NO and NO2 is collectively known as NOx, right? And is very harmful. So straight cough, cold, and you start, your lung get damaged, right? So how does it happen? Because see, you want a high temperature for combustion, but at high temperature, oxygen and nitrogen in the air combine to form oxides of nitrogen. So we were ending up with production of oxides of nitrogen in the exhaust gases of automobiles, and which can't be let out. And so a catalytic reduction was done, right? So that the exhaust gases will go through this catalytic reactor, where the oxides of nitrogen will be converted into nitrogen and let out into the atmosphere. Remember, nitrogen is not a pollutant, but oxides of nitrogen is a pollutant. So if I can convert NO and NO2 into nitrogen, well, my job is done. I am not polluting. I am adding nitrogen only to the atmosphere. A revolutionary development in polymerization is the development of process for the production of linear low-density polyethylene. Linear low-density polyethylene, which is LLDPE. This first L stands for linear, then the other L, well, by now you know it. Okay, so linear low-density, LDPE is low-density polyethylene, LLDPE is linear low-density polyethylene by union carbide and shell. Then also 80s, the biotechnology was emerging. Come to 1990s, Sumayo Lijima discovers a type of cylindrical fullerene known as carbon nanotube, 1991. This material is an important component in the field of nanotechnology. Wow. Remember, in the fourth year, we have an elective for nanotechnology. If good number of students opt for it, we will definitely offer it. Okay, so nanotechnology, improved NOx abatement in the exhaust gases by oxide NOx trap. Toyota improved the automobile exhaust by converting the exhaust gases. So there's another breakthrough. This is an improvement over what has been done earlier. Then 2000s, we are closing in. Introduction of soot abatement for diesel engines by Peugeot, French company, right? Introduction of soot abatement, that is carbon. Soot is carbon, fine dust of carbon, right? So diesel engine, no black smoke, lot of unburned carbon is there. So this was a problem. and introduction of soot abatement was done by Pigod, and ultra efficient production of bulk chemicals. Right, bulk chemicals are the one from which many other chemicals are made. Then green chemistry and sustainability, including biomass conversion, became hot topics. Green chemistry, that is cradle to grave, no pollution, green, sab hare hare, green chemistry, and sustainability without um, uh, degrading the natural resources. Right, biomass conversion, they all became hot topics during 2000. New paradigms and concepts, product technology, process intensification, these all came. And we will be studying something about process intensification in our course toward the end of the semester. Structure of the chemical industry. Now, chemical industry is huge, organic, inorganic, petroleum, polymers, this, that, bioproduct. So let's just try to see how to study this jungle. Right, chemical industry is a jungle, but we will find a systematic method for studying this. In the chemical industry, raw materials are converted into products for other industries and consumers. Remember, raw material becomes product, useful product. If it is not useful, then it is not a product. Right? So by chemical, physical, mechanical, and biological transformations in the most optimum fashion. That is this. Then the range of product is enormous, but the vast majority of these chemicals, about 85% are produced from a handful of chemicals called base chemicals. Just look at this. Just a handful of chemicals, raw materials called base chemicals, they are the ones, which end up making 85% of the entire chemical industry, which in turn are produced from only 10 raw materials. Right? So you have base chemicals. These base chemicals are made from just 10 raw materials. What are these? These raw materials can be divided into inorganic and organic materials. Inorganic materials include air, water, and minerals. Hawa, pani. So, air is an inorganic raw material. Water is an inorganic raw material. हम ये एयर और वाटर इस्तेमाल करके हम कितने रिएक्शन करते हैं. So imagine just 10 raw materials make the base chemicals, and from base chemicals 85% of the products can be got. So the inorganic raw materials are, so the raw materials can be made classified into inorganic and organic, and the inorganic raw materials include air, water, and minerals. Imagine the permutation combination with which a chemical engineer uses just these handful of raw materials to make whole range of products. Then comes oil, coal, and natural gas, together termed as fossil fuels, and biomass belongs to the class of organic raw materials. Right. So, air, water, mineral 3, 4 oil, 5 coal, natural gas, right, and biomass. So, 4, 5, 6, 7. Okay, so we got, these are the major raw materials. Then conversion of base chemicals can produce 300 different intermediates. So remember that coming back here, make from the handful of raw materials base chemicals. Then from the base chemicals, we are going to make more than 300 different intermediates, which are still relatively simple molecules. See, intermediate means they are only midway. They are not the final product. And these intermediates become the raw material for making the finished product. Then both the base chemicals and intermediates can be termed as bulk chemicals. So when we say bulk chemicals, it includes the base and intermediates, right? So bulk chemical doesn't mean, by weight. So bulk chemicals are the sum of base chemicals and intermediates, and a wide variety of advanced chemicals, industrially Industrial specialty chemical and consumer product can be obtained by further reaction step. More reaction, we can make more products. Oh, so we are Banastali, like we know how to study the jungle. Chemical industry can be viewed as a tree-shaped structure, just a tree. See at the bottom, the roots, raw material, CA10, just 10. And base chemicals, right? So the fuels and base chemicals. Then, so this is the next step. Then comes the intermediates, about 300 of them. From the 300 intermediates, I can make more than 30,000 chemicals. Just look at the raw materials here. Oil, natural gas, coal, rock. Rock is minerals, sulfur, air and water. Okay, so these are my main raw material. Then fuel. You can see fuels include LPG, liquefied petroleum gas, gasoline, petrol, diesel, gasoline otherwise called petrol, diesel, kerosene. Then base chemicals, look at some of them. Ethene, propene, ethene is ethylene, propene is propylene, butene is butylene, benzene, the starting aromatic, C6H6, synthesis gas, nitrogen plus hydrogen. This mixture is known as synthesis gas. Similarly, a mixture of carbon monoxide and hydrogen is also called as synthesis gas because using mixture of nitrogen and hydrogen, we can make ammonia and make urea and more chemicals. Or with carbon monoxide and hydrogen, I can make methanol and start making a whole lot of organic chemicals. So ammonia, methanol, sulfuric acid, chlorine, they're all there in these base chemicals. Look at some of the intermediates. Acetic acid, formaldehyde, urea, ethene oxide, that is ethylene oxide, CH2O, acrylonitrile, acetaldehyde, terephthalic acid. So remember our definition was base chemicals and intermediates added together can be called as bulk chemicals. Okay, so base plus intermediate is bulk chemical. Now we go to the final product, plastics, electronic materials, fibers, solvent, detergent, perfume, insecticides, pharmaceutical, advanced chemicals, specialties and consumer products. Final product, the uncountable. So this is our way of studying the chemical industry. Now let's come to overview of the petrochemical industry. A quick run. Crude oil and natural gas are the primary raw material for the production of most organic chemicals. Crude oil and natural gas. So those who have it are rich countries. The first stage in the petrochemical industry is conversion of these crude oil and natural gas into base chemicals. They are lower alkene like ethene, propene, butadiene, aromatics, benzene, toluene, xylene. Remember this combo BTX, benzene B, toluene T, xylene X. This is known as BTX, aromatics. Then comes synthesis gas, mixture of mainly hydrogen and carbon monoxide, ammonia, methanol. This is synthesis gas. Then comes in the second stage, a variety of chemical operation is conducted, often with the aim to introduce now heteroatom. See, remember hydrocarbon means carbon and hydrogen. Now I bring other than carbon and hydrogen, the heteroatoms are oxygen, chlorine, sulfur into the molecule. They form chemical intermediates, acetic acid, CH3COOH, formaldehyde, HCHO, ethene oxide, that is the CH2O, ethylene oxide, and monomers like acrylonitrile, terephthalic acid, and so on. A final series of operations consisting of a number of steps is needed to get advanced chemicals, industrial specialties, and consumer products. Okay, so there we are on to plastics. For example, polyvinyl chloride, PVC, polyacrylonitrile, these are plastics. Of course, you know that there are thermoplastics and thermosetting. We will study them in the polymer industry. Then come synthetic fibers. For example, polyester like polyethylene terephthalate, PET, nylon 6. These are synthetic fibers. And also we have natural fibers, that is regenerated cellulose. We will be studying it. Elastomers. Elastomers are synthetic rubber, polybutadiene, paints and coatings, herbicides, insecticides and fungicides, agrochemicals, fertilizers, ammonium nitrate. Example, many fertilizers are there. Vitamins, flavors and fragrances. Anyone from Kanauj in UP, known as the Aptar capital of India, they make so much flavors and fragrances. Some girl who is from Kanauj should tell us the secrets of Kanauj wale kya banate hain, kaise banate hain. Soaps, detergents and cosmetics, consumer chemicals, cosmetic. You girls know more about cosmetics than I can teach. Pharmaceuticals, medicines of all kinds. Right. Now let's have a look at the top 11 chemical companies in the world. This is by sales. DuPont, USA. DuPont, earlier BASF was the one. Then Dow Chemicals merged with DuPont. Dow DuPont now is the largest company. Right. So top 11 chemical companies in the world by sale. So a few years back it was BASF on top. Then now it is DuPont because it was the DuPont and Dow Chemical two merged and ended up becoming DuPont. Now it is a merged version. Then comes Sinopec, China, SABIC, Saudi Arabia. Remember, SABIC is one of the great companies. Their office in Gurgaon, Dundalo, Ineos, UK, Formosa Plastics, Taiwan, Exxon Mobil, USA, Leondal Basel Industries, Netherlands, Mitsubishi Chemical, Japan, LG Chemical, South Korea, Reliance Industries, India. इन कंपनीज में इंडिया में ऑफिसेज है तो इंटर्नशिप करने का कोशिश शुरू करो, ढूंढो इन सबको. टॉप 10 केमिकल कंपनीज इन इंडिया. पिडिलाइट, ओ जो बनाते हैं ना पिडिलाइट गम, sticking, Pidilite, Tata Chemicals, UPL, that was earlier United Phosphorus Limited, now it is known only as UPL, Gujarat Fluorocarbons Limited, Solar Industries Limited, BASF India, Linde India, Aarti Industries, Vinati Organics, Gujarat Heavy Chemicals, this is under our Apna Dalmia Group, right? These are top 10 chemical companies in India. You just saw top 10 chemical companies in the world by sale. Apna Reliance is there, one of them. Actually, this is the 11th company, that is why I added. Then 10 companies in India. Then comes India's top 10 largest oil and gas companies. Remember, these are chemical companies. Even though oil companies are also chemical companies, they are made into a separate category by itself. Indian Oil Corporation, IOCL, ONGC, Bharat Petroleum, Reliance Petroleum, SR Oil, Kain India, Gas Authority of India, Hindustan Petroleum Corporation, which was earlier under the government of India, now it is privatized, Oil India, OIL, Tata Petrodyne. I think this was the SR Oil, which has now become Tata Petrodyne. These are the top 10 India's largest oil and gas companies. Then come the world's top 10 largest oil and gas companies: Exxon, Royal Dutch, PetroChina, Chevron, Total. Remember the name of a company, Total, Sinopec, Gazprom, Rosenfeld, Reliance Industries, Lukoil. These are the one. I'm just naming these companies. Look up what is the procedure listed in the website of these companies for doing internship. Correspond with them, and they demand a letter from the department. Get back to me and Professor Shukla. We will give you the LOR. You have to work, right? So I'm throwing these names to motivate you. Fight it out. The battle starts. Then comes specialty chemicals. And specialty chemicals comprises low volume, high value chemicals. Remember, I keep telling the phenyl, one bottle is just 30, 40 bucks. And try to buy, one small bottle of a scent or the refill for what is this, no, marker pen, just one or two drops. You can use the pen for several days. So low volume, high value chemicals, they are used in small quantities, but they cost a huge quantity, huge cost. Then specific application. So specialty chemicals by definition are low volume. They are not consumed in huge quantities like, right. And India is gearing up in a big way as a manufacturing hub for specialty chemicals and is expected to steal the thunder from China in coming years. Right now, China is leading the world in specialty chemicals. हम भारत बहुत जल्दी पकड़ लेंगे. Right. Specialty chemical players reported a major boost in volumes and earnings, majority arising out of shift in supply from China to India. So already many specialty chemical production is going in a big way. So the future of Indian chemical industry, specialty chemicals will have a role. I'll just tell you what are these specialty chemicals. The specialty chemicals are under this 1, 2, 3, 4, 5, 6, 7, 8, 9 group. Agrochemicals. These are the pesticides and herbicides and weedicides, agrochemicals. A small bottle of pesticide is not put in, huge quantity. You just mix a small shisha of, pesticide and dilute it. You can spread the whole field, right? Agrochemicals. This is specialty chemical. Flavors and fragrances, kanoj, scents and flavors, rose ether and all, dyes and pigment. Remember, you just put a pinch of a dye into a bucket of water, the whole bucket is colored, you can play holy with it, right? You are not putting, kgs of dye, you are just putting a small pinch, right? So it's a specialty chemical. There is a difference between dyes and pigment. Pigments are surface colorant. Dyes chemically bond with the material and form dye. That is why remember some colors after Holi 1 week also it doesn't go because it forms a chemical bond with the skin. Whereas pigment, the dry powders, they color and they get removed easily. Personal care active ingredient, all those shampoos and what is that fragrances you use, they are all personal care active ingredient. Water chemicals, water treatment chemicals, right? So add small quantities to purify the water. Water chemicals, construction chemicals. There are chemicals added, admixed with concrete, cement, etc. for improving the life of the structure. That is construction chemicals. Surfactant, small quantity of detergent. Surfactants, detergents are the same. So we will be having a study of surfactants in our syllabus. Textile chemical, a whole range of chemical goes in manufacturing the textile from which dress is made. Polymer additives. You know why the bucket you buy in the first year in the college become decolorized by the time it comes to fourth year? You don't even know what is the color of the bucket you bought because polymer degradation, right? The bucket starts cracks and you throw it and buy a new one. Polymer degradation, depolymerization. To prevent them, we add small quantities of chemicals, fire retardant, fireproof, right? So we add specialty chemicals to the polymer to give fireproof. We give for anti-ozonation, oxidation, depolymerization. So all these are specialty chemicals. Then comes now our contract with you and me for the semester is the handout. We are on CHT 305 Chemical Technology, 6th semester BTech Chemical Engineering. Our classes will be Saturday, Sunday, Monday, 11:40 to 12:50 p.m. And we meet in Google Class, Google Meet like today. And our course is CHT 305 CT at banastali.in. What is the learning objective? So process synthesis concept for flow sheet generation. We will see process synthesis, unit operations and unit process, general principles applied in studying a chemical industry, inorganic chemical industries including fuel and industrial gases, cryogenics, sulfuric acid, nitrogen industry. Cryogenics is low liquid oxygen, liquid nitrogen, low temperatures. And nitrogen industries, phosphorus industries, potassium industries, Portland cement, chloralkali industry, natural product industries including essential and edible oil, soaps and detergents, pulp and paper, coal and coal chemicals, petroleum, petrochemical, synthetic organic chemical industries including pesticide, polymerization industries, whole lot of them. Then the textbook will be following for this is Rao, MG and Citic, Dryden's Outlines of Chemical Technology for the 21st century, 33rd edition affiliated East West Press. This is a prescribed book for the GATE syllabus also for this course, Chemical Technology. Then we have reference books, Maugin, Mackay, Depin, Chemical Process Technology. The soft copy of this book, I've already put it in the Google class. We don't have a soft copy of Dryden's Outline Chemical Technology, so you may have to buy it. It's worth keeping. Then Austin GT Shreve is also this R2 has come 2 times. R2 Austin GT is Shreve's Chemical Process Industries, and the good book for reference. R3 reference 3 just Westersteel Chemical Technology, Faith and Clark Industrial Chemicals, and we have several NPTEL videos also available for the chemical technology, heavy and fine chemicals, this is the link, organic chemical technology, this is the link, chemical technology 2, this is the link, so you can see at your convenience. Then the course plan we have given, process synthesis, how to make a flow sheet, hydrogen producer gas, water gas, oxygen, nitrogen, fertilizer industry, NPK, nitrogen, phosphorus, potassium, pesticide, Portland cement, coal and coal chemicals, chloralkali industry. Chloralkali means caustic soda, chlorine, and sodium carbonate. And in the section B, we'll see petroleum industries, petrochemical, which include formaldehyde, acetaldehyde, acetic acid, acetic anhydride, malic anhydride, nitrobenzene, ethylene oxide, ethylene glycol, acrylonitrile, styrene, butadiene. Then we will jump to pulp and paper industry, regenerated cellulose, soaps and detergents, edible and essential oil. Then we move to section C, where we will be having a glance of the polymerization industry for the production of plastics, fibers, and elastomers, sugar and alcohol industry, mete bath, process intensification, which is one of the in thing which is being taught in a large scale. So we have continuous assessment. First assignment, 20th January, you have to submit. I will give the assignment to you by 13th. First periodical dates are 10th to 15th February. And the exact date, Vani Mandir will tell you. Second assignment, 4th March, we will give you the titles by 24th February. Second periodical is 22 to 27th March. And the semester exam is 8th to 24th May. No makeup will be conducted. You can put as much makeup as you want for sitting in front of the computer, but I will give you no makeup. Absentees will be awarded 0 mark. Consultation hours, you can raise your question within the Google class. Queries with reference in return can also be given in email and WhatsApp. Notices, if any, will be displayed in the Google class. And there we are on 2nd January. And tomorrow, we will see the India's expanding chemical industry. So an article came on AICHE journal, and it's a very good article on giving what is the scope of India's chemical industry, which is what I'll be doing in tomorrow, second lecture. And there it is. And mark your attendance. The Google form is there. And have a great evening. Thank you all. Bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay. And today's lecture PPT, I've already put it in the Google class. Stop recording how here. Oh.